In today's class, let us begin with a first simple Java program followed by Java's magic, that is bytecode. Let us move to first simple Java program. In this program, I've started with comments. We call this as multi-line comments. So why we are calling it as multi-line comments? Because multiple statements I'm trying to comment. How to create a multi-line comments inside our program? In order to write multi-line comments, you should begin with forward slash followed by star, and it must end with star followed by forward slash. Next, we have a class. In Java, class is a keyword. Anything which is a keyword will have some special meaning to the Java compiler. Since class is a keyword, we need to write as it is. That is C, L, A, S, S. Everything must be written in lowercase. Followed by name of the class, that is example. The name of the class can be any identifier. When I say any identifier, it can be any name but except keyword. Followed by flower braces. The class begins with flower base and ends with closing flower base. Within this class, whatever we write, we call it as body of the class. Sometimes we call it as members of the class, right? So let us move inside the class. Inside the class, I have written a single line comment. So why we are calling it as a single line comment? Because the single statement I am trying to comment. So how to write a single line comment? In order to write single line comment, the single line comment should be prefixed with two forward slashes, right? So right now, with respect to our program, we have seen two types of comments. One is multi-line comments and one more is single line comments. The most important thing we need to keep in our mind that Java compiler ignores comments, right? Now, if the compiler is ignoring the comments, then the question may arise, then why we should write comments inside the program? The comments are very important thing which we should always write inside our program, because a comments describe what a program does to a programmer who is trying to understand your code. So that's why it is good practice to write comments inside our program, right? After single line comment, we have written a method called main method. So why we are calling it as main method? Because the name of the method is main, that is main. Now I would like to ask a question that it is mandatory that I need to write main everything in a lowercase. Let us assume I have written the main method in uppercase, that is m in uppercase and ain in lowercase. If I write main like this, my program compiles, my program runs. What's your answer? Just think. If I write main like this, that is m in uppercase and ain in lowercase, my program compiles successfully. But if I try to run the program, it throws an error stating that my class does not have a method called main, that is main, everything in lowercase. So that's why it is mandatory that you need to write main method everything in lowercase. As you know that Java is a case sensitive programming language. So anything which needs to be written in lowercase must be written in lowercase. Anything which needs to be written in uppercase must be written in uppercase. So that's why here I have written into. It means that the main method should be written in lowercase. It should not be written in uppercase, right? Yeah. Now let us see why the main method is prefixed with public, static, and void, right? So let us move to public. Public is a keyword in Java. As we know, anything which is a keyword needs to be written as it is. That is, public should be written in lowercase. Public is called as access specifier in Java. So what is an access specifier? An access specifier controls the visibility of the members of a class. Right now, with respect to our code, the main method is prefixed with public. The public says that the main method can be visible outside of the class. Now the question arises, why the main method should be visible outside of the class? The main method should be visible outside of the class because the main method is invoked by a program that is running outside of your class, and we call that program as JVM, which stands for Java Virtual Machine. In order to put things simple, it is a JVM which is trying to invoke your main method, and it is a code which is running outside of your class called example. So JVM, in order to invoke your main method, the main method should be prefixed with public, right? Now, followed by public, we have a keyword called static. The keyword static means that a JVM can invoke your main method without creating an object of a class. In other words, a JVM can invoke your main method without creating any objects of a class. Next, we have void keyword. Since our main method is not returning any value, we have prefix main with void. Next, inside the parenthesis of the main method, we have string args. Right? Args is an array which is of type string. To this array, that is args, we can pass command line arguments. So how to pass command line arguments, we are going to see at the end of this slide, right? Yeah. Followed by main method, we have followed by main method, we have an opening flower base which indicates the method begins with, right? Then we have a closing flower base which indicates the method ends with. So within this opening flower base and closing flower base, we can write any statements which we write inside this opening flower base and closing flower base. We are going to call it as body of the method. So right now the main method is having only one statement called system.out.println. So here, using the statement, what I'm trying to do, I'm trying to print a message calls. This is a simple program onto my output screen, that is to my monitor. So let us see what is this system. A system is a predefined class in our Java that provides access to your system. Followed by out. Out refers to output stream that is connected to your console. When I say console, this output stream will get connected to your monitor. Followed by, we have println statement. Println is a function. So any statement which you write inside this println statement, that is, we have written here, this is a simple Java program. So any statements which you write inside this println statement will be sent to the output stream and it gets displayed on our monitor, right? Let me remove all these markings. Let us assume we have typed this program in a notepad or notepad plus plus or any editor of your choice. So once you type the program, we need to save the program. In order to save the program, we need to pick a name to the program, or we need to pick a name to your file. So what name we can pick? We can pick any name or any specific name. To say the truth, we can pick any name of your choice, but that is not a good practice. So Java suggests whenever you want to pick a name to your Java program, we need to pick the name of the class which contains main method. With respect to our program, the class called example contains main method. So that's why we need to save our program with name called example followed by .java. .java indicates that this is a Java program. So once we save the file, we need to compile the program. In order to compile the program, we need to use a tool called Java C followed by the name of the program which you want to compile. Here Java C is the tool and example.java is the name of the program which we want to compile. So once we compile, we get a .class file. What is the name of this .class file? The name of the .class file is nothing but the name of the class which we have written inside our program. It is not the name of the source file, right? So now, what is the name of the .class file? It is example.class. And we call this example.class as bytecode, and this bytecode is platform independent. What do you mean by platform independence? Let us assume this example.java I have compiled in Windows operating system. If I compile in Windows operating system, I got an output called example.class. In other words, I got a bytecode. Now the same example.java I am trying to compile in Linux operating system. If I compile in Linux operating system, I will get the same bytecode which I've got in Windows operating system. Now let us compile the same program in Mac OS. If I compile this program in Mac OS, I'll get the same bytecode. So what it means, irrespective of what operating system I'm trying to compile, I'm going to get the same bytecode. So that's why we're going to call it as a platform independent. Here the platform refers to your operating system. That is, irrespective of which operating system you're trying to compile your Java program, you're going to get the same bytecode, right? So once we got bytecode, that is example.class, we need to run the program. In order to run the program, we need to use a tool called Java followed by the name of the .class file which contains main method. So with respect to our program, the .class file example contains the main method. So that's why we should write Java example. The most important thing we should observe here is we should not write example.class. Just we should write example. And one more thing here I would like to highlight. Right now my program contains one class. So that's why here I got only one .class file. Let us assume my program is containing two classes. One class is box class and one more class is example class. Now if I compile the program, then I'm going to get two .class file. The name of one .class file is box.class and the name of second .class file is example.class. So let us assume my program is having 10 classes. If my program is having 10 classes, then 10 .class file is created. But right now with respect to our program, since we have only one class called example, we are getting only one dot class file, that is example. I repeat, the name of the dot class file is based on the name of the class which you written inside our program. It is not based on the name of your source file, right? Yeah. Now let us move to this, that is Java example. So in order to run the program, we use a tool called Java followed by the name of the class which contains our main method, right? Now, in order to run a Java program, we need to have JVM inside our operating system. So that's what it shows. So now inside our operating system called Windows, a JVM has been installed. Inside our Linux operating system, I have a JVM installed. Inside our Mac OS, I have a JVM installed. Here you need to observe the JVM is platform dependent. It is not independent. What my platform dependence means, for each operating system, it has its own JVM. You see that Linux has its own JVM, Mac will have its own JVM, Windows is having its own JVM, right? So in order to run a Java program, it is mandated that JVM needs to be installed in your operating system. Now the question comes, how to install this JVM? JVM is installed automatically when you try to install JDK, that is Java Development Toolkit, right? So this dot class file will be given as input to your JVM, and the output of your JVM is nothing but it is your executable code, right? So that's why we are calling JVM as platform independent, right? Inside JVM, we have a small component called just in time. In short, we are going to call it as a JIT. What this JIT will do, it is going to take part of your bytecode, it's going to compile into an executable code on demand basis. Now let me summarize this block diagram, right? Now if I compile this example.java, I'm going to get a dot class file. It is nothing but it is a bytecode. This bytecode we are going to call as a platform independent. So why I'm calling it a platform independent, irrespective of what operating system I'm trying to compile, I'm going to get the same bytecode. So once we get this bytecode I can run in Windows operating system, I can run in Linux operating system, I can run in Mac OS. For example, let us assume that this example.java I've compiled in Windows operating system. So once I compile, I got a dot class file which is a bytecode. Now this bytecode I can run in either Linux operating system or I can run in Mac OS. Why? Because this bytecode is a platform independent. This is not true with respect to C or C++. In C or C++, if you try to compile a program in Windows operating system, it is mandated that we need to run the program in the same operating system, but which is not true in the case of Java, right? Now let us move to this command line arguments. How to pass command line arguments to this array called args. These command line arguments can be passed when you're trying to run the program. How to run the program? We need to use a tool called Java followed by the name of the dot class file which contains main method. So after this we can pass some additional values. It can be any values of your choice. So right now here I pass two values, that is high and 1. This high and 1 we are going to call it as command line arguments. So these two command line arguments, that is high and 1, we are going to pass to this array called args, right? So once we pass high and 1 to this args array, then my array looks like this. That is, args array will have high at 0 location, will have 1 at location 1. In other words, args of 0 will have high, ARGS of 1 will have the value called 1, right? Yeah. If you try to print the statement, that is ARGS of 0 and ARGS of 1, will get the output as high and then 1. You see that ARGS of 0 is having the value called high, ARGS of 1 is having the value called 1, right? Let us move to next slide. Here I have taken this diagram from the previous slide. So let us discuss Java's magics, that is bytecode, one by one. Output of Java compiler is not executable, rather it is in intermediate form called bytecode, and it is a .class file. I think that's what we are seeing. So once I compile a Java program, I'll get a .class file, and we call this .class file as bytecode. In other words, we call this bytecode also as an intermediate code, right? So let us move to next point. So what is bytecode? Bytecode is a highly optimized set of instructions designed to be executed by Java runtime system, which is called Java Virtual Machine, right? So let us move to next point. Java Virtual Machine interrupts the bytecode to executable form. So this .class file will be given as input to your JVM, and the output of JVM is nothing but it's an executable code. Just in time, that is JIT, is part of the JVM, selects portion of bytecode and compiles into executable code in real time on a piece by piece demand basis. I think this we have discussed in the previous slide. That is, just in time, which is a part of JVM, selects a portion of bytecode and compiles it into an executable code on piece by piece and demand basis, right? I hope you enjoyed this video. Thanks for watching. Please do subscribe.